Okay, so once again, welcome everyone to the channel, and this is the part 8 of our binary tree series, where we're gonna solve the question number 5 and 5 names of find the largest value in the each tree row, which is the medium problem on the lead code. And here we are given the root of a binary tree, which written an array of the largest value in the each row of the tree. So in the example 1, we say the input 13253 null and 9, which is this tree, and we got our output 139, which is basically in the level 1. When you see there's the only one node, so we need to print that node in the answer, which means output. And in the level 1, sorry, in the level 2, we see there are the two nodes like 3 and 2, so we need to print the maximum of the both the nodes, like in what is the maximum value of the both the this node and this node. So we need to print 3. And at the level 3rd, we see there are the three nodes 5, 3, 9. So what is the maximum value of the both? We need to print the 9. And same at the example 2, we have a 1, 2, 3. So assume in the mind you have a tree which has a 1, which is the root node, and at the left you see the 2, and the right you see the 3. So there are the maximum chances that 3 got a max value, then the greater than the 2. So we need to print the 3 right next to the 1. And hopefully you understand the question. And now we see the solution, that how this code gonna be run. We just apply the a concept of a level order traversal in this question, so that we're gonna run this code in the big O of n time complexity. So after that, we just write the vector int answer, in which we store our answer, okay, and apply the base condition, which is if our root is equals to null pointer, then we need to return answer, okay. After all that, we just need to make a queue, which is we already done at a level order traversal. We made a queue of a tree node root, sorry, not root, basically a queue. We apply the more extra space, okay. After all that, we just apply the while loop, checking if the queue is not equals to empty, sorry. Okay, so after applying this, we just assign a size variable, which is equals to a q dot size, which helps us to write the for loop in this solution. So q dot size, okay, and that's it. After that, we just apply a max value type variable, which is generally help us to denoting the answer, that how the answer came. Like if we have to check the maximum value, then how you check? You have to apply a variable name, okay, some variable which is generally store the both the values, and then check that what is the maximum of the both nodes. That's why we need to have apply a int max val is equals to int, sorry, int min, okay, that's all. And after that, we just apply the for loop, which is for int I equals to 0, and I is equals to a size, and then I plus plus, okay. This is the for loop, and as we do in the level order traversal, we apply a write a next node name a current, which is to store the q dot front, and then we apply the pop function, so that our next value came in the queue, and then we operate our functions in that queue. Means we change the values alternately when the what's the question, the demand of the question that we do in the that's queue. That's why we need to apply we need to make a current node like this tree node, okay, which is named as current, which store the q dot front, okay, q dot front. Wait, we do the wrong thing here. We just need to push root, because at the base condition we have a a root present in our queue. It's basically a level order traversal code. So q dot front, after that semicolon, and we apply the q dot pop, sorry for the spelling mistakes. And after applying the q dot pop, we just write the max val is equals to max. This is the a very important line of the code. You just need to understand that what I want to say, and what this question, what the solution want to compile, how it's compiled the both the operation, which is written in the form of input and output. So apply the max, it's a STL that it's check basically how much you are when you write this. Let's suppose write a two variable name which store a store 20 and b store 30. So max condition check that what is the greater element in the both the a and b, who is greater. So max condition is generally for this. So at this point we need to apply the max val as well as our current dot value. Okay, after all that apply the semicolon on this and writing if our current left, let's check that is there the present possibilities of the current dot left is present in our tree or not. Yes, current dot left is present, means the left node of the current is in the tree. If it is in the tree, so we need to push current dot left in the queue. Okay, so applying this, and after all that writing exact this function, copy this and okay, paste in that here, and you write the queue right. Okay, and here you store the queue right. Check the both left as well as the right node of the tree, so that we basically check the what is the maximum value in the both the level. And this function is check that what is the maximum value in the both the nodes. In this place you check basically in the which is the greater number, 3 and 2. So this operation helps us to know that what number is greater in the queue. And after all that we just apply the right. Okay, and apply this here. We write we need to push answer dot push back max value. Okay, here we apply this, and then after all this is the last line in which we print our answer. That's it. And can we see any error in this code? No. So we need to run this code. Yes, both the test cases are passes, and now we're gonna submit this code. Okay, to check what is the time complexity of this code. Let's take a little bit time, but it's gonna be a run. Okay, it's a big ON code, so we doesn't need to hesitate for the solution, and we clearly understand that what the solution says to us. And what I want to explain you, I hope you understand in a careful manner. And whatever doubt in your mind, please ask in the comment box. So this is for the today, guys. Meet you in the next video. Keep learning.